That's the broken code.
So he's out here.
Okay.
Yeah. You're gonna read these books today, but I'm not assigning them to you. At the end of class, you're gonna put it right back in the closet. You're just gonna put it right back in the closet like this. The purpose of that is if you want to use your book on the next test, I'm hoping everybody can find the pages, because that was kind of a problem when we were carrying them out. That students just had a hard time keeping track because they weren't ripping out very well. So you're just gonna read it and put it back to there. I might even just leave these up here. Sorry, I selected them. And if you want to turn them out. Points and
We're gonna get that. Have your
all right, so you have 3 calculations you're doing for homework. Do you want to use it right now? Or? They work all year, so if you still have assignment passes, you can use them anytime. They don't expire. I actually have juniors to bring them to me from freshman year. Will you pass those down that road? And I'll get the rest of you guys in a minute. How do we do it? So we want to plug in for x and find y. So this is saying x is -2, so working in exponential equations, when we plug it in, it would be y equals 5 to the -2. Did anybody get an answer in a calculator for 5 to the -2? What'd you get? 0.04. Now I want to show you the fraction version of that. It's usually more likely to be used. This is 1/5². Negative exponents lead to fractions. So the 5 goes under 1, and the -2 becomes positive. So this would be y equals 1/25, which is what I gave you at, is it 0.4? Yeah, 0.04. That's the equivalent of 1/25. So honestly, I prefer 1/25 more. That shows an understanding of negative exponents, but 0.04 is also very good. Number 2. All right, we have this equation, -2 times 9 to the x. Just as a heads up, this could easily be written with parentheses. All right, so sometimes it's parentheses, sometimes it's the product dot. So we're going to put a 1/2 in right where x is. It says evaluate when x equals 1/2. So this is -2 times 9 to the 1/2 power. Does anybody remember writing 9 to the 1/2 in radical form? We watched several videos about how to convert a rational exponent to a square root. Vladimir? The denominator goes down and around. The exponent stays up high. So 9 to the 1/2 is the same as the square root of 9. This was 2 weeks ago. Write it down if you don't remember it. 9 to the 1/2 is the same as the square root of 9. Do y'all know the square root of 9? 3. Okay. So 9 to the 1/2 power is the same as 3. You have full rights to use a calculator on that. In fact, the Google Scientific Calculator will do all of this for you if you type it in correctly. So this is just -2 times 3. Always do your exponent before your multiplication. So the answer to number 2 is just -6. And this would correlate to a point on a graph. The point would be 1/2, -6. Because we plugged 1/2 in for x, and we got a -6 out, and that's x, y. Now y'all do number 3. I'll wait now that I've done 2. If you need a minute. Yeah. No, it doesn't. Yes, it does. Yeah, it does. Okay, if you have an answer or a question. I'll deliver you a book. Raise your hand if you haven't got a book yet. 3 people? I'll bring it. Raise your hand if you haven't answered to number 3. None of y'all do? Karma, what are you working on? What about this though? Logan, did you do it? What'd you do? So it's 4 times 3 to the 4th power. 3 to the 4th takes the priority in the order of operations. So that's 4 times 81. Gabe, what'd you get? Y equals 324. Anybody have questions about exponents before multiplying? Plugging in and evaluating. All right. So I'm going to get 3 more people books, and then this is the page I want everyone to go to. I mean, I'm not assigning it to you. I want everybody to go to page 532 and start reading about writing exponential functions. Page 532 and start reading about writing exponential functions. You're actually going to take notes on the back of this handout. Fine if you want to do it on notebook paper, but I know I'm going to hand this handout back to you. So. Pass that to your left, please.
This one, the reflective across the you're not going to find it. So we got to solve this. Then we got to do this equation for 5 down. And this one, we do the this equation. We do it for unit right. You understand? Yes, Nathan?
Okay, so you just plugged in and evaluated exponential functions. Today's actual challenge is to write them, and you're writing them in the form of y equals a times b to the x. And there's a ton of real-world application for exponential functions. Okay. Who else didn't get a paper? Now you have an extra. Did everybody get one? All right. So this is the growth of a bacteria population after X days. It says find the population after 12 hours and 5 days. So they've provided 1, 2, 3, 4, 5 points. What this means, this 0, 3 here, that's after 0 days, there are 3 bacteria. So when we look at our exponential growth function, A was the initial amount. So in this situation, A will be 3. So whatever is paired with 0, in this case 0, 3, that 3 is the A value. And I think I labeled this Friday. I said that A value is the y-intercept. The solution here says use the table of values to identify the y-intercept and the growth factor. I see the y-intercept here is 0, 3. The growth factor is this multiplier. It's timesing 4 every time. That means each hour, the number of bacteria multiplies by 4. So this would be your A value. And the times 4 pattern is the B value. So it's 3 times 4 to the x. A lot of students will mistakenly make this base 12. Brianna, could you imagine making this a 12? 3 times 4 is 12. It's reasonable. However, exponents always take priority over multiplication. So fight the urge. This is not 12. This is 4 to an exponent and then multiplied by 3. So that's pretty much how you write an exponential equation. You figure out what the y-intercept is, and then you figure out the pattern. On the back of the handout I just gave you, write this down. You have full permission to shorthand, but these are the steps you're going to use on your assignment today. No. So you're going to write these steps down on the back of your handout. This is, how do I write an equation if I'm just given a graph? How do I figure out my exponential equation?
Do I get 0.69 by not writing?
I am going to collect this handout. So go ahead and write it. While you're writing, I'm going to pass out some other handouts that I have graded and put into focus. Please do not lose these. You're allowed to use these on your next test if you choose, right? So please keep these when I hand them to you. Should I just keep them to the next test?
Yeah, please.
Hand them out like the day before. Okay. I just thought you might want to see them, but okay. I want to use them. I want you to take your earbud out. Are they gone? Step 1. If given a graph, identify 4 points to make a table. Be sure to include the y-intercept. So that's where x is 0, whatever other point is. Step 2, make a table. Some of your problems are going to give you a table, and you can just skip to step 2. Step 3, use the pattern to identify the growth factor. Step 4, write the equation. All right, well, I see a 0 here. So that means the y-intercept is 250. So now I'm at y equals 250 times. But what is the pattern? That's 250 to 150. That's dropping 100. 150 to 90. That's dropping 60. 90 to 54. This just is not as easy as the example. So there's a trick or a tip, and that is to make fractions. So the fractions you want to make is the second y over the first y. So I'm going to put 150 over 250 and reduce it. I'm going to put 90 over 150 and reduce it. And maybe I do one more. I'm going to put 54 over 90 and reduce it. So what do I mean by reduce it? You're allowed to divide it in a calculator. Okay. Neil?
She's at the door. She's at the door.
It's not how we keep it. Just calm down. Just go in the bathroom. You just go in the bathroom.
So what do you guys want to do? Do you want to divide it in a calculator or do you want to reduce it in fraction form? You pick. Okay, I'm going to go with fraction form. We can compare. I would reduce the zeros first to make this 15 over 25 and then reduce it to make it 3/5 because they both divide by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. So, and I'm going to go ahead, since it's a fraction, write this as 3/5 to the x power. What is that, 0.6, you guys?
Oh,
Did you do it in a calculator to
No.
get 0.6? It's 3 divided by 5 in a calculator. Just do the Google one. Do Google Scientific or Desmo Scientific. And I never would have allowed that in the past. But actually, the state exams calculator looks a lot like the Google Scientific calculator. So we're actually now encouraged to tell you, hey, use the Desmos calculator, use the Google calculator, get comfortable with it. So we did it. Does anybody have any questions about number 1? This is the answer. Try number 3. Eva, please save your email. So Nathan, what are your thoughts on here? Do you know A? Yeah. How do you know it's 5? So it's the y-intercept. So whatever is paired with 0, that's your a value. It's the y-intercept. This is a. You could just put it in the box. Alright, so we have the a value. It's the initial amount. Even when we were writing word problems for growth and decay, the initial amount went in the a spot. Well, starting at 0 is the initial amount, so that really tracks. The y-intercept and initial amount, same thing. Now we have to figure out the pattern. So the step said if it doesn't give you a table, to make a table. So if I was to see these ordered pairs in table form, it would be 0, 5, 115, 245. Take a minute and try to figure out the pattern here. How are the y values changing? All right, one person has it. Avery, do you know the pattern? 2 people, 3 people have it, 4 people have it, 6 people have it. I mean, that's enough for me. What's the pattern? It's timesing by 3 every time. Times 3 times 3. So that means b is 3. So our equation is 5 times 3 to the x power. So that is number 1 and 3. Now we have to do 4 through 12.
4 through 12.
Should say 1, 3 through 12, I guess.
Yes, that's too many.
Go ahead and try number 4. There you go. Y-intercept, the a value. What do we think the b value is? This one's a little more obvious to me than the other ones have been. So for dividing by 2, we're actually gonna look at it as timesing by 1/2. So I'm gonna, well, you have to write the equation. So here I go with step 1 and 2, making the table. I know whatever is the y-intercept goes in the a spot, so that's a done deal. I have to figure out the pattern. It's called a constant ratio. When I look, it's being divided by 2. Dividing by 2 is the same as timesing by 1/2. So in this case, our b value is 1/2. If that's difficult for you to see, just set up a fraction called a ratio, and you would do 21 over 42, 10.5 over 21, and 5.25 over 10.5. All of these reduce to 0.5. And that's your base, your b value. It's the same as 1/2, and it's the same as dividing by 2. So our answer is 42 times 1/2 to the x power. And that is the same as, that might be counted right, 42 times 0.5. That's decimal form, and that's fraction form. These are equivalent. You get credit for both of those. All right, the graph shows the number of Y computers infected by a virus after X hours. Find the number of computers infected after 90 minutes and 6 hours. So they're asking you to first write the equation and then use the equation for this word problem. Some students could do it though, just finding the pattern, I think. If they just sat, and you have plenty of time on this test, just sat and look at the pattern, I think you could come up with it just using logic and reasoning if you didn't have the equation. So we're doing y times a to, y equals a times b to the x. Our a value would be 1. What's the b value? You know it, Carmen? You know the pattern? Okay. You see? No. You see it?
Oh, I see.
What's that? She raised her hand for you, Devin. Isn't that nice of her? You know the answer?
Yes.
Okay. And Genevieve, do you know the answer? Yeah. And you know the answer? Okay, what's your question?
For the first one, there's two questions. Oh, yeah, I already have the next question. Yeah, we put one for eight.
One.
No, not really. So that's a great question. So these are going by multiplying 4. Good job to all of you for figuring that out. Genevieve, did you write it in a table or did you just look at it?
I just looked at it.
Did anybody take the time to write out the table like this?
No. So much work.
Okay, a couple people did. Okay. If the numbers are more difficult, just take the time. It might help you see the pattern. So yeah, that's times 4 every time. And that's how we arrive at b equals 4. Gabe's question is, do I really have to put the 1 times in there? And the answer is no. Like on big ideas math, they probably wouldn't even count it right. So if the initial value is 1, you don't even see it. It's invisible. So this would be your answer. Now it says find the number of computers infected after 90 minutes and after 6 hours. We haven't done that yet. All we've done is written the equation. How many hours is 90 minutes?
1 hour 30.
Yeah, so 90 minutes would be 1.5 hours. So for 90 minutes, it would be 4 to the 1.5 power. And then we have to do it again. It's asking us to do it twice. So we're going to do it again. So we'll do y equals 4 to the 6th power. So you already have your calculator out and ready from bell work. Go ahead, 4 to the 1.5 and 4 to the 6. It's a lot of computers after 6 hours. What is this is?
0. What?
You're doing it wrong.
So 8 computers after an hour and a half. And 4,096 after 6 hours. So that virus is spreading quickly.
That's not good.
When things quadruple, they spread quickly. Yes, this is how diseases like computer viruses and biological viruses, they spread in the same way. I don't see how there couldn't be. I think there's always new viruses. Alright, so that's a computer tech application question. Moving on to number 6, we're talking about the value of a boat. So more of a finance question. The boat's value is decreasing over time. It's not as good anymore after a few years. So let's see how it's decreasing. This is called exponential decay. A times B to the X. This boat started out as $30,000. It's a nice boat. We got to figure out B, and this one looks less clear. I'm going to use a table. Starts as 30,000. After 1 year, it's only 24,000. After 3 years, 15,360. What kind of pattern is that? No. Do the problem twice. Find it after 2 years, and then find it again after 8 years.
Yeah, I did.
Logan, have you found B yet for the boat? What's the decay rate of this boat? 1.25? That seems really high. I'm going to switch you around. Did you do 30 over 24? Yeah, do that again and put 24 over 30. You have to put the second one over the first one. 4 over 5. Very good. And I love that base. Just so you know, that's 0.8. Every year, it's worth 80% what it originally was. That means it's decreasing 20%. Our equation's going to be 30 times 4/5 x, or 30 times 0.8x. So it's decreasing 1/5 or 20% each year. You put the second value over the first one. And if the numbers are going down, your base should be less than 1. Okay, we still have to answer it. It says find the value after 2 years and then again after 8 years. So 2 years would be 30 times 0.8 squared. And 8 years would be 30 times 0.8 to the 8th.